Hello, everyone, and welcome and thanks for joining today's webinar on the importance of warehouse KPIs. So we recently attended Sapphire Now a couple weeks ago, and warehouse management and extended warehouse management were commonly asked about at our booth. So during our webinar, we will focus on EWM for warehouse KPI enhancements, optimizing your labor footprint, and improving your pick rate. Today's speaker is Sanjay Adi, and Sanjay has vast knowledge in the areas of SAP WM, LE, MM, and EWM, along with executing SAP solutions across third-party warehouses, MES systems, and various RF scanners and RFID. And these are across global locations and industry verticals. Now, I did get to see Sanjay's experience firsthand at Sapphire Now and was amazed by the knowledge that he has on today's topics. So on the next slide, I'm going to go over some quick housekeeping tips. So if questions come up during the webinar, please type your questions in the panel as shown in the example, and we'll go ahead and address those at the end. On the next slide, I'd like to quickly introduce Krypt to those of you who are less familiar with us. So Krypt was established in 2008 and is a leading SAP consulting partner. Although we do operate globally, we consider ourselves a boutique consulting firm that lives by our founding principles of innovation, collaboration, and drive. These principles now have allowed us to complete over 800,000 SAP consulting hours in various industries, and our services focus around implementations, upgrades, and customizations around various SAP solutions, including trade, transportation, warehouse planning, IBP, and HANA. And we also offer proprietary solutions, integration services, and do work closely with SAP for ramp-ups and testing. On the next slide, I'd like to quickly share our thought leadership. We strive to be thought leaders in the supply chain ecosystem, and we have accomplished this by authoring books in addition to writing blogs and white papers, which are available on our website. Moving on to the next slide, this is an overview of our proprietary offerings, which complements the SAP suite. I wanted to briefly highlight Krypt Connect located in the middle of the solution. This particular solution can be integrated with non-SAP ERP systems, which many people do find valuable. So as you'll see on our next slide, over the years, we've had the opportunity to work with a variety of companies within the SAP supply chain, and some of those are highlighted on this slide coming up. Sanjay, you can advance the slide. Sanjay, you can go ahead and advance that. Thank you. Yeah, so as you can see, there are some examples of different companies that we have done projects for. So with that, I'm going to go ahead and pass it over to Sanjay to kick off our demonstration.
Yeah, thanks, Deb. Good morning, everyone. Thank you once again for taking time off from your busy schedule to join the session on our webinar on the importance of warehouse KPI. As Deb has mentioned, my name is Sanjay Adi. I have 13 years of experience in SAP warehouse management, EWM, MM, and integration of warehouse management and EWM solutions with LIMS, MES, third-party warehouse like Manhattan, and so on. With that, let's move on for the agenda for the day. The agenda revolves around the warehouse KPIs. We would essentially go through some of the warehouse KPIs that we have in a modern day warehouse, followed by we would discuss the functionality of EWM slotting, followed by rearrangement, task interleaving, and we'll also see how the implementation of EWM slotting, rearrangement, and task interleaving can be utilized to achieve some of the very important warehouse KPIs. And lastly, definitely not the least, a cost savings, how we can achieve a considerable amount of cost savings via implementation of slotting, rearrangement, and task interleaving. Now, the objective of the session, and therefore, is to go through a few of the warehouse KPIs and understanding of EWM slotting, rearrangement, task interleaving, the functionality of EWM slotting, rearrangement, task interleaving, how these functionalities when implemented can help achieve some of the KPIs and the savings therefore. Now, before I go into As you can see on this slide, there's a pictorial representation of a retail store. Now, for this webinar and for the sake of discussion, we have taken retail store as a talking point, but the functionality of slotting, task interleaving, and rearrangement can be implemented across any industry vertical. So, going back, we all do go to shopping malls and stores quite often than more. Now, what happens is that if we go to a shopping mall during winter, you would see that the winter garments are placed closer to the aisle so that the customer can see them and pick whatever they want. Whereas if you move further inside the stores, you would see that the summer garments are stashed somewhere else. So this is how they keep it so that the customer can pick whatever they want during winter. However, during summer, that if you go to the same shopping mall, you would see that the scenario changes a bit. What happens is that the summer garments get more prominence as compared to the winter garments. Now, as you already know, this is very simple for a retail store to do. Is all they need to do is basically during winter season, they pick up the summer garments, push it back, and during the winter, they move the winter garments closer so that the customer can pick up. Now, this is very simple in a retail store, but imagine when this has to be done in a very large warehouse of, let's say, 100,000 square feet with a product line running 10,000 plus and a storage bin of 6,000 plus. It can be high rack, bulk storage, open storage, it can be anything, you name it. So how would a warehouse like this would do a functionality of seasonal, taking into consideration seasonal changes? Now, this can be seasonal, this can be fast moving goods, slow moving goods, it can be any type of goods in the nature of products. Now, how this can be done? Now, the way this can be done is therefore the topic of the discussion for the webinar today. But before I go into the topic of the discussion, let's understand and let's review a few of the warehouse KPIs that we have. I'm sure you all know this, but I'm just reiterating. Increase of warehouse throughput, which is nothing but a measure of comparative effectiveness of an operation inside the warehouse. An efficient pick and put process, which can be achieved in any warehouse via an efficient storage and retrieval process. Excuse me. An inventory carrying cost. Of course, the inventory carrying cost is of the prime importance in any warehouse. Inventory carrying cost is nothing but the cost which the warehouse has to keep the inventory, the direct labor, the indirect resource cost, and so on. The labor footprint. Now, as you will all agree with me, that labor is it takes up a very big chunk of the resource in cost in any warehouse, in any industry. So if we can effectively reduce the labor cost and reduce the cost of the labor which is utilized, we can achieve considerable amount of increase in savings. And faster order fulfillment, it's a buzzword these days that we need to execute customer orders at the topmost priority and the fastest mode possible. Lastly, and definitely not the least, inventory turnover. It is how faster the company replaces the products that are being sold and brings back to the warehouse so that it can satisfy requirements for the customers. Therefore, some of these KPIs can result in increased savings. Now, when we talk about KPIs, this brings us to the discussion. One of the primary discussion for the day is EWM slotting. Let's understand how EWM slotting works in a real-time scenario. This is, as you can see, a high rack storage in a pretty decently fairly big warehouse. So pallets are stacked here. And let's assume that this is the packaging line. This is the packaging line from which the outbound pick process is executed. So this is where the fulfillment station or the staging area, as they call in the warehouse, is, from where the trucks get loaded and shipped to the customer. Let's assume that this packaging line is closer to the aisle here. If somebody has to pick a pallet from here, travel all the way from here to the packaging line. Whereas if a pallet is placed closer to the packaging line, the distance that the forklift driver would require to travel and move the pallet from here will be much shorter than the pallet residing here. So the obvious choice for any warehouse supervisor or a picker or a loader would be essentially to go for option 1. Now let's assume that this is a fast moving product and we have to ensure that the customer fulfillment is done in the fastest way possible. Then we would ensure and we would like to have the product placed somewhere here in these aisles so that the picker can load it faster and go back and pick the next order. Let's see now how EWM slotting can help us in achieving this. One of the functionalities that EWM slotting uses is a put away control indicator, which is updated in the product master. What it does is essentially in EWM, where a packing is done and the pallet is created in EWM, the put away control indicator or the PASI helps to move the pallet from the goods receipt area into the storage bin. Now, slotting essentially uses put away control indicator as one of its indicators to perform the slotting run. There are other indicators as well, as you can see on the screen: storage section and bin type. Let's now see how this is done in EWM using put away control indicator. I will just touch upon briefly on the few configuration items which are there in EWM slotting. This is basically the nerve center or the backbone of EWM slotting using placement put away control indicator. For the purpose of this webinar, I have taken two primary fields for slotting. One is the number followed by the warehouse product group. Let's understand how these are interlinked. We are going to do a slotting run for the product that is marked in red box 2403 for the warehouse GEWM. We are assuming that this product is a fast moving product. That means we would like to move this product into a location which helps us to pick the product faster. Now, the fields here, the warehouse number this field is utilized by the system. The warehouse product group is linked to the product group that is there in the product master. And the way that is linked is via a master record which is a master data condition record. So in the condition record, what we determine is that this condition record would work for warehouse GEWM, which comes from the product master, and a warehouse product group, which is 0001, which is a fast moving product. This condition record tells the system when the EWM slotting is done that the product has to go into a storage type 0010 using the placement indicator 0010. Let's now see how a slotting, this is the configuration, the backbone of the configuration, how the slotting is done. Let's now see how the slotting is executed in foreground in EWM. This is the front screen, the foreground screen of this product when a slotting is executed in EWM 2403. This is the product. Once a slotting has been executed, the system updates in the slotting tab of the product master in EWM with a slotting status as to the date and time, the time zone, that telling any person who is looking into it, run has been executed in such and such time frame. What essentially it does is the following. On the screen that you see here, there are two put away control indicators. One is a put away control indicator. Here it says AEGR. This put away control indicator is essentially updated when the product master is created or uploaded into EWM first time after go live. This is the product control, the placement control indicator which the system uses for all its processing of pallets after the goods receipt has been done from the inbound delivery. This pushes the pallet into a location which is determined by the warehouse supervisor or any person who is doing the master data maintenance. However, based on the condition record, the system updates the put away control indicator, which is called as a planned put away control indicator, as 0010. The purpose of slotting is to analyze the optimal bin, as we have seen, and identify the placement control indicator, which the system should actually use based on the condition record. In this example, the product 2403, since it's a fast moving product, the condition record updates the product master with the put away control indicator as 0010, requesting the warehouse person to move the pallet to 0010. Now, this is only what slotting does. Now, slotting is proposing, therefore, an ideal location where the put away has to be done, the pallet has to be moved. But this is definitely not the end of the story. Once this functionality, this product functionality is executed, the product master is updated. The next brings us to the EWM slotting, EWM rearrangement. So the slotting essentially identifies in a warehouse that the product should ideally be kept here, but the physical pallet is still lying here. Now let's see how EWM rearrangement can help in getting this done. What EWM rearrangement does is basically consider this put away control indicator, the planned put away control indicator, and move the pallet to an optimal location where it should go. The way it is done in EWM is via a warehouse task. Let's see how rearrangement does that. What rearrangement does is it creates a warehouse task after the slotting run has been executed. It takes the task and assigns it to a specific queue, which is determined during the warehouse task has been created, picks the pallet and moves the pallet to the optimal as has been decided by the rearrangement run. Now let's see in EWM how this is executed. This is the foreground processing of EWM for the same product 2403, for which the slotting run has been executed. This is the existing storage bin where the pallet currently resides. And based on the slotting run and the planned put away control indicator updated in the product, the optimal storage type, the section, and the bin type has to be determined by the rearrangement run. Once the rearrangement run is executed, the system creates a warehouse optimization warehouse task for the product 2403 to move the pallet from 0020 from the this bin coordinate to the optimal bin coordinates, thereby moving the pallet to the bin. The warehouse task is assigned, as I mentioned, to a specific queue, and any resource working on the queue can pick up the pallet and move it to the optimal bin. So essentially what it does is it moves the pallet from the current location that it resides to an optimal location. Now let's see how this functionality of slotting and rearrangement is interlinked to the KPI that you see on the screen, a faster order fulfillment by effective put away and pick process. The key contributors for this functionality is an ideal stock put away location, optimal positioning of pallets, reducing the travel time for picking operation, definitely not the least, rearrangement based on nature of demand and the nature of product. Now, the way this can be achieved via EWM rearrangement is if we can determine the ideal location for put away, which is done by EWM slotting, the planned PASI can be suitably updated so that the put away can be done in the optimal location. The optimal positioning of pallets, once the slotting has been executed, the task can be created via rearrangement functionality, and it can be picked up from a source location to a destination location. The travel time therefore can be reduced if a pallet can be placed to a location which is faster and easier to be picked by the loader or the picker. Definitely rearrangement based on nature of demand for this webinar, we have considered that a product, it will be a fast moving product. We can pick any conditions based on the functionality that we want. EWM standard provides certain conditions. We can make our own customized as well. Now, let's understand another warehouse KPI, which is the warehouse throughput. As you can see on the screen, 40% of the labor in any warehouse is the labor cost in any warehouse. Now, if we can reduce the labor cost by any percentage, it amounts to savings in a warehouse. Now, the number of items moved for a specific period divided by the labor hours would essentially give us the throughput time per item. If the throughput time per item is multiplied by the average labor hour, then we get the labor cost per item. Now, this brings us to another functionality which is a topic of discussion for today, is how EWM can help us in optimizing the labor footprint that we have in the warehouse. The answer to that from EWM perspective is EWM task. Let's understand how this functionality can help us. As you can see on the screen, this is a pictorial representation of a goods receipt area where the pallets have been unloaded and packed and ready for put away. Normally, what would happen in EWM is a warehouse task essentially would be created. The warehouse task would be assigned automatically to a put away queue. A resource would be assigned to that queue, and a resource would take the pallet from the goods receipt area and put it in the put away final destination bin. What would he do next? Essentially, after the pallet has been put, he would bring back the empty pallet back into the goods receipt area to do another transaction, another task completion. Now, if we assume that the travel time for empty pallet is 3 minutes and a particular resource is doing 50 put away per shift, essentially he's actually having 150 minutes, that is 2.5 hours per shift of lost time due to empty return journey, the pallet returns. So 2.5 hours per shift. That is 12.5 hours in a week of five working days. If we activate EWM task interleaving, what the system would do is, after the put away task has been completed, the system would assign automatically using the system guided functionality in EWM RF user interface. The system would assign the queue, which is for a picking task, or it can be internal movement, it can be replenishment, it can be reorganization, it can be anything, if as long as the task has the source location as this one where the final put away has been done by the first task. So the operator would be then assigned where he would require to pick a pallet from a bin which is closer to where the first task has been executed. He picks the pallet and the warehouse task is executed by the resource or the operator, and he drives it to the goods issue area. Thereby, on its return journey, he doesn't return empty, but he returns with a pallet. So EWM task interleaving can help us maximize the utilization of resources or forklift drivers or any kind of resource or stacker crane, whatever it is there in any warehouse, so that it can be optimally utilized. We have done a kind of a, let's understand how we can do a bit of a cost savings when these functionalities of EWM slotting, rearrangement, and task interleaving are implemented in tandem with each other. Let's assume that the average picking time is 5 minutes per item, and the number of items picked per shift is 50 items. The total time, therefore, per person is 250 minutes. Now, using these three functionalities, if we can achieve just 1 minute of savings in the entire process that you can see on the screen, the average pick time per person reduces to 4 minutes. If 50 items are picked, the person can spend only 200 minutes per shift. Therefore, a savings of 50 minutes, which amounts to 12 additional picks, which might not mean a lot, but if it's multiplied by 4 operators, 48 items and for per shift can be done. If the pick cost is $2, then a savings of $96 per shift. And if $96 per shift is in 3 shifts in a particular day and a 5-day work week, a savings of $1,440 in a week can be achieved. Just an example we have taken just for savings of 1 minute, but if functionalities of slotting, EWM, task interleaving, and replenishment is rearrangement is done, then optimization can be done in many ways than one. With this, we come to the end of this webinar. Please feel free to ask questions that you might have and anything that you would like to discuss.
Yeah, all right. Thanks, Sanjay. And we did have a couple questions that came in while you were giving your presentation, but if there are any additional ones, certainly feel free to put those in the question box. One that came in says, or asked, can a rearrangement task be separated from other warehouse activities like put away and picking?
Yes, for sure, yes. So we can actually create different queues, and based on termination functionality which RFUI presents to us, we can separate tasks, rearrangement tasks from other tasks. And if we activate interleaving, we can help as the resource or the picker or the loader, whoever is working on a queue, to jump queues and move in seamlessly between multiple queues.
Okay, perfect. Thanks. Another one also talks about interleaving, or asks about, says, can we restrict and limit a resource to work on interleaving of activity to specific queues?
Yes, for sure. That is also possible. If we say that our queue, a resource is limited to a specific queue, then we, in the resource master, we can restrict a resource and say that this resource can only work on a specific queue. Now, a resource can be a forklift, a handheld gun, a stacker crane, and any resource can work in any user. Any user can be assigned to any resource. So essentially, we can restrict via resource group how the user can be restricted to work on a specific queue.
Okay, and then the last one that was asked says, what happens, I want to know about after the planned put away indicator is updated.
Yeah, so after the planned put away indicator, this is a very interesting question. After the planned put away indicator is updated, although the system has the put away indicator placement, stock placement indicator, or put away control indicator updated, essentially it would still try to move the pallet to the original location. But this is a master data change. So essentially, after a slotting run is done, it is advisable to update the put away control indicator with the one that has been updated by the slotting run, so that in the next inbound, the pallet is moved to the location or optimal location where it has been done by rearrangement.
All right, perfect. All right, so those are the questions that did come in. So with that, it doesn't appear there's any additional ones. So we did want to thank everyone for taking time out of their day to attend our webinar. If you have any questions, certainly feel free to reach out, or if questions come up later, we're happy to address them. The contact information is on the screen for your reference. So with that, that does conclude our webinar. Thanks for attending, everyone.